Okay, good morning all of you. We are discussing about the properties of the soles or colloids. Already yesterday we seen one property of the sole is nothing but colligative property. Colligative property of a sole is always less than colligative property of the solution, because in the solution more particle is there, they may aggregate together becoming like a colloidal particle. Then finally in the sole number of colloidal particle will be less, corresponding colligative property will be less. I told finally one conclusion also, colligative property of a sole is equals to 1 by 1000 times of colligative property of the solution. Yes or no? Another colligative property is important for board as well as competitive examination. See, definition he will ask, what is the Tyndall effect? Indirectly it is nothing but optical property of the sole. Means we were discussing already in introduction class of colloids, I told. Yes or no? Solution, Konnurs Tyndall effect, colloids, suspensions are showing Tyndall effect. Indirectly it is nothing but light scattering property. Light scattering property of property by colloidal particles are nothing but sole particle. Yes. What is this one? I will explain to you. See, first of all, I am taking solution amount. If you take solution, yes, I am taking solution here. Okay, through the solution I am sending light rays. I am sending. This is nothing but light source will be here. Starting from here. So whenever you send the light rays through that solution, in the solution what will be there? Solute will be there as well as solvent will be there. Observe very carefully, very simple concept. In this what will be there? A smallest, very tiny solute particles will be there. Okay, whenever you pass light rays through the normal solution, okay, without any reflection, it is passing through the solution and coming at another side. Is there any reflection of light by solution particle? Means if any reflection is there inside the solution, we have to feel the path of the light rays. Are we feeling the path of the light rays inside the solution? No. Why? There is no, right? That is only no. In case of solution, no reflection of light by which particles? Solute particles. Solute particles. Why there is no reflection by solute particles? Solute particle size will be very small. It is similar to which one? Less than 1 nanometer. Thus far, there is no chance collision between light and solute particle. Thus far, there is no reflection. Thus far, inside the solution, we can't feel the path of the light rays. That's why what we can tell, in case of solution, there is no Tyndall effect. But what I am doing, instead of solution, I am taking sole. I am taking. You observe very carefully. I am taking sole. I am taking. Okay, same thing I am doing here. Observe like this. Okay, this is nothing but which one? Sole will be there. Inside the sole, what will be there? Both colloidal particles will be there, and also this Gaussian medium will be there. So whenever you take like this, okay, these all things has to be studied by taking ultra microscope in the perpendicular direction to the incident light rays. For example, light rays will be falling in the x direction. We have to observe all things from the y direction. Means it is nothing but ultra microscope you are taking here. Ultra microscope. Okay. Then what happening, you know? Okay, whenever you are seeing like this, you are sending light rays like this, but in the sole, you are seeing the total phenomena in the right angle direction to the incident light direction. Then what we can feel? We can observe the path of the light rays in the sole. Why? Yes, sir. The path appears in the form of which one? Cone shape. Why it is happening like this? Why this path we are feeling in case of sole? Why? Reflection. Light is reflected by which one? Colloidal particles. Then the reflected light we are feeling in the form of which one? Cone shape. The whole phenomena only we are calling as Tyndall effect. So whenever, very simple Tyndall effect or optical property of the soul means we are sending light rays through the soul, then we have to observe the things in the right angle direction to the light falling direction or light propagation direction. Then the path of the light rays will be appears in the form of cone shape. It is due to light reflected by the colloidal particles. Sir, why not here? Why here means here colloidal particle size is bigger. It is around how much? 1 nanometer to 1000 nanometer. Definitely what happening? The incident light rays will be falling on the colloidal particle undergoing reflection. Then we can feel a path of the light rays in the soul. The phenomena is calling as a Tyndall effect. All of you getting on? Same thing, Tyndall effect we can observe in our daily life also. For example, you sat in theater. So from here, it's above on your head, the projector beam is coming. Okay, the screen will be there. Okay, in between screen and projector starting point, we can feel some dust particles. Yes, sir. Yes. Why? Because dust in air, solid in gas, solid aerosol, also nothing but soul. Yes or no? What happening? From projector light is coming, that light will be falling on that dust particle, then the dust particle will reflect that falling light, that light we are feeling, then we can observe that dust particles in the air. So anyway, dust in air is nothing but soul. Same, I given one more example. Like this, we sat in one dark room. Okay, through the windows, very little bit light rays is coming into the dark room. Then also we can feel light dust particle because of reflection of light by those dust particle in that room. Such phenomena is nothing but soul. The whole concept we are calling as a Tyndall effect. Are you getting or no? Yes, here one component. This is only for theory purpose. I am telling that Tyndall effect is observed when based on size of the particle. If suppose the Tyndall effect is observed when particle size, nothing but which particle? Colloidal particle size is similar to wavelength of light falling, wavelength of the light which is falling. Did you got my point? If suppose wavelength will be more, particle size is too small, there is no collision. There is no collision means there is no reflection. When we can observe the Tyndall effect? When the colloidal particle size will be similar to the wavelength of light which is falling. You check in 2019 JEE main paper, he asked this condition only. In which case we can observe the Tyndall effect is one of the points. Which options will be there? A, B, C, D. You have to choose them. You see, one more case will be there. So large difference between, so large difference in refractive indices. I think you learned in physics. What is the representation of refractive indices? Anybody? A new letter. So large difference in the refractive indices between dispersed phase and dispersion medium. Both are almost having same refractive indices, means there is no proper reflection. Whenever they are having large variation in that refractive property, what happening? We can feel that falling light ray very clearly. So that's why we can observe the Tyndall effect when colloidal particle size should be similar to the wavelength of light which is falling, and a large difference in refractive indices between dispersed phase and dispersion medium. Then we can get very clear a Tyndall effect. Means then we can fall down the light rays on the soul. It will be appears very clearly like a bright cone shape. That is nothing but a Tyndall effect. All of you getting or no? Yes. Now I will tell you one more property of the soul is nothing but colors. Colors of souls. Yes, very important concept now. Okay, what is the responsible for colors of the souls? Yes, like solution, we have souls. They also have different colors. For the reason behind it. The colors of the soul depends on size of the colloidal particle. Size of colloidal particle. I will give you explanation. Do you see carefully? I am explaining that gold soul I am taking. Okay, gold soul means, for example, I am taking first one soul. In that particle size is, for example, particle size is for example 200 nanometers. 200 nanometers will be there, like this will be there. These are which particle? Gold colloidal particle disposed in a dispersion medium. For example, if you take 200 nanometers size having gold sole, it is appears in a red color. The sole is appears in red color. No, I am taking gold sole only, but relatively bigger size I am taking. For example, this is also gold sole only, but the size of the gold sole is increasing. Here how much I taken? 200, but here I am taking size is equals to 500 nanometer. Anyway, 200, 500 means is under range of colloidal particle or no? 1 to 1000, yes, colloidal particle. I am taking small size of colloidal particle having gold sole appears in red color. Same gold sole only, but relatively bigger size I am taking. Then it is appears in golden color. Indirectly, golden color means what amount? Yellow color. Yes, where changes is coming? Why changes is coming? Same sole everything, but here small size colloidal particle, but here relatively bigger size. So from this, I want to tell one relation between size of the colloidal particle and wavelength of the appeared color. Anybody? Yes, you see here 200, 500. This is small size colloidal particles, and we are getting red color. You know Vibgyor. Yes or no? Vibgyor. Vibgyor. From violet to red color, what happening among? Wavelength is increasing. Now we are taking small size of gold sole, then it is appears in red color means wavelength of that appearing color will be high. No, same I am taking but relatively big size. Whenever you are taking big size, the sole is appears in yellow color, means it is comes less than red color wavelength, means we are getting wavelength will be low. Can you tell the relation? Smaller size colloidal particles having more wavelength colored solution, and bigger size particles are having lower wavelength. That's why can we tell one relation? Wavelength of light or wavelength of color of sole is inversely or directly? Inversely proportional to size of colloidal particle. Yes, these are helpful to solve the bit sum in competitive examination. As the colloidal particle size is increasing, corresponding appearing color of the wavelength will be decreasing. I explained very clearly. You see, one more point I want to tell here: color of the sole. Color of sole is also depends on in which way observer receives that light, receives the light from the sole. Okay, one reason is size of the colloidal particle will influence the color of the sole. What is the one more reason? Color of the sole is also depends upon in which way the observer will receive the light from the sole. Just you can see. I am taking milk. Commonly I am taking milk is taking. Milk is it sole or no? Yes. Liquid disposed in liquid is nothing but one type of the emulsion. Anyway, it is a sole. Okay, now I am taking in a one bowl, I am taking or one glass or transparent bowl, I am taking milk. So into that milk, if you observe, if suppose light ray will be falling from this, okay, then light ray will be bounced back like this. That is calling as reflection or transmission. It is calling as a reflection. Okay, now you taken milk bowl and light ray will be falling here. If you can see like this, what color you can feel? Not white color. You can feel some other color. Anybody? If you see like this, then what happens? You are feeling light bluish color. Means it is appears in blue color. Okay, no, same milk I am taking, but I absorbed transmitted light. Transmitted light means the passing through the medium and then coming outside. That is calling as a transmitted light. Transmitted light. Okay, if you can feel from this direction, for example, you have a transparent glass beaker or glass of milk is there. Through that light ray will be falling here, but I am observing from this direction. Then it appears in another color. Lightly it is in red color. So same sole, everything particle size will be same, everything will be same, even though the color of the soul will be changing by which direction we are observing that soul. In case of reflected light, we are feeling bluish milk, and if you feel from see from transmitted light direction, it is appears a little bit red color. Once after going home, once you check this one, definitely you can observe this one. So finally, the color of the soul will be depending upon particle size of the colloids and also in which way we are observing the colors of the soul. That is also important. Now, I am explaining one more property, is nothing but mechanical property. Mechanical property of soul. Okay, this mechanical property of soul is also calling as Brownian moment. Brownian moment. This is also important for board examination. He will ask like some all together definitions like a 5 marks also. What is this one? Mechanical property of the soul, also calling as a Brownian moment. What is this one? Just you see. Okay, you have first of all dispersion medium. Okay, dispersion medium means I am taking like this. One liquid I am taking, in that the colloidal particles has to be dissolved or has to be mixed. To this I am adding dispersed phase, also calling as a colloidal particles. Okay, I am taking colloidal particles here, I am taking, and I have to dissolve in that one. Okay, first of all, before mixing, first you study the dispersion medium. If you take pure dispersion medium, in that dispersion medium is in a continuous motion. Continuous motion means continuously it is moving. Okay, then what happening? The kinetic energy of dispersion medium will be very high. Did you observe or no? For example, you taken water. So water molecules continuously in the motion. Because of that one, what happening? The water molecules is having too much kinetic energy. Now into this one, what you are adding? Clay particles you are adding. After adding clay particle, what happening? It starts mixing with the dispersion medium. While mixing is what happening? While mixing, what happening? Between dispersed phase and dispersion medium, collisions will be taking place. Means after, for example, you feel this is like a clay. So after mixing, what happening between dispersed phase and dispersion medium, collisions will be going on. You observe very carefully. Between dispersed phase and dispersion medium, collisions is going on. Okay, in that collisions, what may happen? Anybody? Clay having any motion initially? No. Kinetic energy will be zero or very less. But after dissolving, what happening between clay particles and water molecule, collisions will be going on. In that collision, something is happening. Anybody? Yes, kinetic energy is transferred from dispersion medium to dispersed phase. Why? Because already dispersion medium having more kinetic energy. That only write down. From dispersion medium to dispersed phase, kinetic energy will be transferred. After transferring kinetic energy, then what happening? Kinetic energy of dispersed phase particle will be increasing. Then they won't sit calm. What they will do? They are in random motion. That is only we are calling as zigzag motion. That's only we are calling as dispersed phase particles or having a random motion. That random motion only we are specially calling as zigzag motion. There is no particular pattern. Zigzag motion. That zigzag motion only we are calling as Brownian moment. Why? Because it is discovered by Brownian. That's why we are calling as a Brownian moment. So how can you show that one? The dispersed phase or colloidal particles are having like this no proper direction of the motion. However, it is going on. That's only we are calling as a zigzag motion. That's only we are calling as a Brownian moment. Once again, you see. So while preparing source, what is the meaning of mechanical property or Brownian moment? First of all, we have to take the dispersion medium. The dispersion medium basically having motion continuously. The meaning is what? Dispersion medium particle has too much kinetic energy. Into that one we are adding dispersed phase. Basically dispersed phase kinetic energy will be almost zero. After adding, what happening between disposal phase and dispersion medium, collisions will be going on. In these collisions, what happening, kinetic energy will be transferred from dispersion medium to disposal phase. Automatically kinetic energy of disposal phase particle will be increasing. Then disposal phase particle will also start moving randomly, means jigsaw, no proper direction, no conditions. However, it will be going like this. That's only we are calling as zigzag motion. That's only specially calling as Brownian movement. Okay, I am telling that this Brownian movement is the responsible for stability of soul. Why Brownian moment is responsible for stability of the soul? What is the meaning of stability of soul? When we will call soul is stable, always disposal phase will stay with the dispersion medium. Compulsory they have to mix it with one another, then only it is calling as a stable. For this stability, Brownian moment is the reason. Are you agreeing or no? Yes, why? Because of this random motion of the collider particle, what happening? They won't sit calm. Means if they are settled down, precipitate. It's not happening. Why? The dispersal phase is continuously in the motion in dispersion medium. That's why, because of Brownian moment, always it will be staying along with the dispersion medium. That's why it is one of the reasons for stability of the souls. And I want to tell one more thing. So to get a maximum Brownian motion, what are the conditions? Means I want more Brownian momentum or high Brownian momentum. Means I want more speed of the collider particles. I want. What are the conditions? Yes, very good, Amma. First case you have to take small sized which one? Collider particles. Then yes, if you take small size having much speed, then Brownian movement will be more, then stability will be more. And what is another reason with respect to viscosity of the dispersion medium? You taking clay particle in water, same clay particle you taken in oil, what happens? Yes, the momentum of the clay particle in the water will be more than oil. Why? Yes, viscosity of water will be lesser, so momentum will be high. But oil viscosity will be more, then momentum of clay particle in that will be less. That's why we want more viscosity of dispersion medium or less viscosity? Yes, we want low viscosity or less viscosity of dispersion medium. Then compulsory the Brownian momentum is high. Brownian momentum is high means collider particles moves very faster. Very faster means indirectly meaning is what they have much interest to stay with the dispersion medium. Then they are becoming very stable. See the concept. These are important amount. Don't take it light. These points are very important. I told Tyndall effect 1 point, here 1 point, color 1 point. All of you got my concept? Yes. Yes, a very important concept, charge of souls. Yes, we have mainly two types of the souls. One is positively charged souls and negatively charged souls. There is no chance for neutral souls. Why? Why? These charges depends upon charge on the colloidal particle. If colloidal particle carries some charge, then only they ripple together, they will not become like a precipitate. That's why the colloidal particle should carry either positive charge or negative charge. There is no chance to neutral, because if neutral colloidal particles is there, they aggregate together becoming like a precipitate. That's why only we have two types of these souls. One is positively charged souls, another one is negatively charged. I will explain to you. See very carefully. Already have maximum idea. Still I will explain. First of all, I am taking a PPT amount. freshly prepared precipitate I am taking. Actually, this is having very big size like this. I explained already yesterday peptidization concept. Okay, its size is more than 1000 nanometers. Yes or no? But these are made up of so many small aggregations. For example, I am taking this is the freshly prepared silver iodide. Okay, those all are aggregated together. Size is too big. That's why it's calling as a precipitate. To this, what I am doing? I am adding a potassium iodide. I am adding. While adding, condition should be there. What is the condition? Adding electrolyte should have a common ion with precipitate. What is the common ion here? It is becoming like K plus ion. What is the common ion will be here? That common ion will be preferentially undergoing adsorption on the surface of the colloidal particle. Then all these particles are becoming same charge. Because of same charge, they always repel together. After repelling together, the total precipitate will be break down into smaller size pieces. That's what we calling as a sol. So I will write that concept only here. All silver iodide particles is absorbing iodide particle from Ki. Then they all are becoming negatively charged particles. Yes, like this will be going on. This is only we are calling as which one? Sol. Okay, now concept is what is the important information here? How the colloidal particles is getting charged? Can you explain the concept? How colloidal particles is getting charges? While preparing source like peptidization method, from outside we are adding electrolyte. From the adding electrolyte, a suitable ion may undergoing adsorption on the surface of the colloidal particle. Then all particles are dispersed from one another and break down into small pieces. In this process, every particle will adsorb one particular ion. So then automatically what happening? All colloidal particles are becoming the same charge. That's why I am writing here all colloidal particles. All colloidal particles are having a same charge. Are you getting or no? Yes. Okay. Now what is the colloidal sol charge? Yes, colloidal particles are carrying a negative charge. No, that's why it is calling a negatively charged sol. No, if suppose colloidal particle is carrying a positive charge, can I give one example? Yes, you see, yesterday we done know, if you take freshly prepared ferric hydroxide, FeOH taken thrice, PPT actually it is. PPT means its size is more than 1000 nanometers. But in that so many ferric hydroxide particles will be there with different sizes. To that, yes, to that we are adding FeCl3. After adding FeCl3, what happening? It is becoming like Fe plus 3 plus 3Cl1, which is preferentially undergoing adsorption on colloidal particle. Common. That's the only reason I have to tell. How the colloidal particles are becoming charges? Means from adding electrolyte, which is common ion with precipitate, that will be undergoing adsorption on the surface of the colloidal particle. Like that, all colloidal particles are getting the same charge. Based on that colloidal particle, we are calling them as either positive or negative. Okay, now which particle is undergoing sticking here? Fe plus 3. Yes or no? Like that, all FeOH thrice particle is sticking on its surface. Fe plus 3 particles. Then we will all the colloidal particles are carrying same charge, that positive charge. That's why the sol is calling as a, if colloidal particles are carrying positive charge, then we will call it as positively charged sol. No transfer neutral source. I told already very clear explanation for that one. All of you clear? Yes. Now I will tell you some important information here. See how what things will be going on further. For example, you have a sol. This one only I am explaining here. See carefully. So while preparing, what will be here? Silver iodide particles will be there. On every silver iodide, what is coming on sticking? I minus. But where K plus is going? Iodide I minus particle is going sticking on the colloidal particle. But where K plus particle is going? Yes, very good. This K plus particle is going into dispersion medium. It won't come outside. Why? Because it can't jump up. Means it will be going into the dispersion medium. So in the dispersion medium, which particle